Hello students, welcome to my channel. In this video, I am going to discuss about different type of fuzzy set operations. In last video, I have already discussed about introduction to fuzzy logic and difference between fuzzy set and crypt set and how to create a membership value or membership function and so on. So please watch that video. Mm. So now let's start. Today's start is fuzzy set operation. So at first go to my app Sukhen's tutorial. You will get solve university question paper that will be very helpful to you for your upcoming semester examination, and module wise or chapter wise class note in PDF format and MCQ with answer, live classes if required. So my app name is Sukhen's tutorial, and go to description box, click that link, and also you can go to Google Play Store and find the Sukhen's tutorial and then install. So this app basically very helpful for students. Okay, so let's try the Sukhen's tutorial app. Chalo start kori. Fuzzy set operation first is union operation. So union operation, uh, A union B. This is a set and this is a B set, and A union B. That means, for example, in case of fuzzy set operations, in case of fuzzy set operation, a mu of A union B of x is equal to maximum of mu of ax comma mu of bx. That means maximum, maximum of mu of ax and mu of bx. For example, this is a set A, this is a set B, and set A variable content like x1 and membership value is 0.7, x2 membership value 3.3, x3 membership value is 0.9, and so on, and as well as set B, x1 like x2 membership value, x2 membership value is 0.5, x3 membership value is 0.7, and so on. So what is the result of this union operation in fuzzy set operation? Fuzzy set operation like this. uh, x1 0.7. Why 0.7? Because 0.7 and 0.2, this is the maximum of the set A and B. That's why go to the x1 comma 0.7, and x2 x2 means 0.5 is a maximum, that's why 0.5 here, and 0.9, that's why 0.9 is here, and 0.4, this is a 0.4. So this is the union operation. That means maximum element or maximum membership value to find of set A and set B. Then intersection operation means minimum minimum of set A and set B. That means this is a set A, set B, minimum is minimum like this. In 0.7 and 0.2, minimum is 0.2, and set A, set B, minimum is 0.3, set A, set B, minimum is 0.7, and 0.1. That means 0.2, 0.3, 0.7, 0.1. So this is a intersection operation. That means we find a minimum element of both in between two sets. Now complement operation, that means uh, complement formula is mu of A complement x, that means 1 minus mu of ax, 1 minus mu of ax, just like this. 1 minus mu of ax for x1, 1 minus 0.7, 1 minus 0.7 for this purpose. 1 minus 0.7, that is 0.3, and 1 minus point 3, that means 0.7, and 1 minus 0.9, this one, that means 0.1 and 0.9. So this is basically a mu of A complement, mu of set A. When we find a mu of set B, that means 1 minus zero point 0.2, that is a 0.8, this is a 0.5, this one 0.3, and this one 0.6. So this is the complement. Now product operation means A into or A dot B, that means multiplication of set A and set B. What is the result like this: x1 comma 0.14, that means 0.7 into 0.2, that means 7 into 2, 14, and 0.3, 0.5, that means 15, 0.9, 0.7, that means 63, 0.63, 0.1, 0.4, that means 0.4. This is the product operation of the fuzzy set operation. Then equality, set A and set B, whether we checked whether set A or set B equal or not, equality check. Mainly this formula is checked equality or not. So mu of Ax is equal to mu of Bx. Here uh, here set not equal, so there is no result of this. Now power. Now power of A to the power P. uh, Mu of A to the power Px is equal to mu of A x P. What is the result? If P is equal to 2, then suppose for this one, zero point 0.7 to the power 2, 0.7 to the power 2, that means 0.7 into 0.7, that means 0.49, 0.4, sorry, zero point 0.3 to the power 2, that means 0.9, 0.9 to the power 2, that means 0.81, 0.1 to the power 2, that means 0.1. So this is the power. When P is equal to 2, result is like this. And algebraic sum means A plus B, that is set A plus set B. Set A set B formula is in fuzzy set operation, mu of Ax plus mu of Bx minus mu of Ax into mu of Bx. That is a sum of algebraic sum of fuzzy set operation. What is the result? Result is like this: mu of Ax plus mu of Bx. Ax, that means 0.7 plus 0.2. Wait a minute. 0.7 plus 0.2, that means 0.9, minus mu of Ax into mu of Bx, that means minus 14, 1 4. 0.7 into 0.2, 14. That means what is the result? 0.76. In same way, x2, that means zero point 0.3 plus 0.5 is equal to 0.8. That means 0.8. This one 0.3, 0.5 plus minus of multiplication of zero point 0.3 and 0.5, that means 15. This is a 65. In same way we can calculate x3 and x4. So this is the result of algebraic sum of A plus B in fuzzy set operation. Now bounded sum, that means XOR or A XOR B. Formula is minimum of 1 comma summation of mu of Ax plus mu of Bx, summation of set A and set B. That means what is the result? Result is 1 comma summation of ax and axb summation of 0.7.2, that means 0.9, তাহলে minimum of 1 comma 0.9, that means 0.9. So this is the result. And second, for a second one, that means x2, for x2 summation of mu x mu b, that means 0.3 0.5 summation is 0.8, and minimum of 1 minus 0.8, that is 0.8. Okay, so in same way we can calculate x3 and x4. Now algebraic difference a minus b, this is the a minus b. Ek minute. This is the algebraic difference a minus b. A minus b formula is mu of a union b complement, mu of a union b complement x. What is the result? Result is first we complement. At first we find out the complement of bx. That means bx means already discussed complement 1 minus this one. That means x1 0.8 comma sorry x2 minus 0.5 comma x3 0.3 x4 0.6. So how to find b complement? B complement formula is 1 minus mu of bx, 1 minus bx. That means b complement x is x1 minus, देखो 1 minus 0.2, 1 minus 0.2 means 0.8, 1 minus 0.5 means 0.5, 1 minus 0.7 means 0.3, 1 minus 0.4, that means 0.6. So this is the b complement of set b. Then union of a and complement of b. For example, this is a union operation. Union operation means already we know about intersection. Intersection of about that is a minimum of set A or set B. In between set A and set B, we find out the minimum of set A and set B. Set A is 0.7 and set B is 0.8. That means first one is x1 comma, that is 0.7, and 0.3 0.5, that means x2 0.3, 0.9 0.3, that means x3 comma 0.3, x4 comma 0.6, and 0.1, that means 0.1. This is the result. So at first uh, we find out the complement of set B, that is 0.8 0.5 0.3, and intersect operation between set A and complement of set B. That means intersects means uh, minimum of set A and set B. Set A means x1 and ax, and set B means complement of this one. So this one and this one minimum is 0.7, right? Set A and set A 0.3, and 0.9 and 0.3, this is a 0.3, and so on. In this way we can find out algebraic difference formula. Okay, next fuzzy set operation, last one is Cartesian product. Cartesian products means A multiply by B, mainly we used in matrix purpose. Formula is minimum of mu x minus mu bx. What is the result of this in this example? A minute. Ax, this is the x1.2, x2.3, x3.5, and so on. This is the set A, set B, and minimum. देखो minimum of set A, set B, minimum of set A, minimum of mu ax1 and mu of bxy. That means this is a minimum. Minimum is 0.2, and this one and this one. देखो this one and this one. That means 0.2 and 0.6. Minimum is 0.2, and this one is this one. That means 0.2. In first cases or first row, we find out the point 2, point 2 and point 2. Then second row, for second row purpose, a minimum of mu x2, mu x2, mu of ax2, mu of bx1, mu of bx1, that means point 0.3 and point 0.8, that means point 0.3, point 0.3, point 0.6, that means point 0.3, and point 0.3, point 0.3, that is a point 0.3, and point 0.5, point 0.8, that means point 0.5, point 0.5, point 0.6, that means point 0.6, sorry, point 0.5, and point 0.5, point 0.3, that means point 0.3. And last one is point 0.6, point 0.8, minimum is point 0.6, point 0.6, point 0.6, minimum is point 0.6, point 0.6, point 0.3, minimum is point 0.3. So this is the basically point 2, point 2, point 2. This is the basically a result using this formula, and result like this. Sorry, and result like this. So this is a Cartesian product in fuzzy set operation. Okay, thank you.